We're going to finish our factoring completely notes. You can put today's date at the top. And this was the packet we started yesterday. Let's start with example number 5. The first thing you want to do is determine if there's a greatest common factor. And when I look at both of these terms, I don't see anything common to both. So there is no greatest common factor. You might also initially think that 16 is greater than 1, so maybe master product would be helpful. But when I think about the factors of 16, truthfully, I can't find anything that would add up to 0 in the middle, so master product, I believe, is not going to work. The only other thing that I notice is that 16m squared and 1 are both perfect squares. So this is possibly a difference of perfect squares. The only problem is this is not a difference, this is a sum. So going through all of our techniques and not being able to find anything that will work tells me that this problem is not factorable, and this one is done. In our next example, again, we're going to start with the GCF. So you want to find numbers and variables that are common to both that can be removed. So looking at the numerical values, I think 2 is common. And the first term has 3y's, the second has 2, and the last only has 1. But all the terms are able to give up at least 1y. So that means the greatest common factor is 2y. So I'm going to remove that from all 3 of these. And our leftovers leave a trinomial behind. So now we have to decide how to approach the leftovers. I see that 4y squared is a square, but 3 is not. So this is not difference of perfect squares, but I do see that a is greater than 1, so that means that we want to use the master product. So I'm going to move forward with that. We're going to multiply 4y squared and 3. Remember, you can stop the video at any time to try the examples on your own before I reveal all the parts. So now let's make a list of factors for 12y squared. We know that they have to sum to negative 13. That tells me that both of my factors have to be negative in order to produce a positive. So you can see all the factor pairs, there's not as many. And the grouping that adds up to negative 13 is the first set. I'm going to take the trinomial that's left and I'm going to write it as a sum of 4 factors using my new values of negative 1y and negative 12y. And then we're going to split this into 2 halves. So in the front half, I'm going to remove 4y as the greatest common factor. And that leaves y minus 3. The back half, they only have a common factor of 1, but we have to decide if it's positive or negative. In order to have y minus 3 left over, I do have to pull a negative 1. And then my final answer includes the previous greatest common factor of 2y, and then the 2 quantities that I just came up with. And this problem is now completely factored. Okay, moving on to number 8. Does this have a greatest common factor? I don't see one. Are my terms squares in the front? No. It is in the back though, but since the front and the back are not both squares, that's not going to work. And it looks like master product is going to be our option. So we're going to multiply 8x squared and 49. 392x squared is our master product. That is quite large. It's likely we'll have a large set of factors. So if we start to list our factors with 1 and 392, and we're going to try to find all possibilities, I know that my sum has to be positive 42x. That tells me all my factors are positive. And as you go through, I can see that the last set, 14x and 28x, does add to 42. So now I'm going to write that as a sum of 4 terms. Again, you can put 14x first and then 28x, but I'm going to split this. So 8x squared and 28x, they have a 4x in common, and that leaves 2x plus 7. For the back half, they do have a 7 in common. Again, it could have been negative, but I can see as I divide by +7, I am getting the same common factor. So when I'm all done, I have 2 binomial factors, and this problem is completely factored. For our last problem, we again want to start with the greatest common factor. So we want to pull out a number or a variable or both. So when I look at this, I believe that I see a greatest common factor of 25. So what does that leave behind? You'll notice in my leftovers, the first term and the last term are both squares. So it's possible we could use a difference of squares. The only thing different here is I do have a middle term. So while they are squares, it won't be a positive sign and a negative sign. It's going to have 2 of the same signs, and they're both going to be positive so that we can obtain 4xy. So we're going to separate the front term, and we're going to separate the back term. So we are using a difference of squares process, but it is the same sign. And I'm going to still include my GCF of 25. Because both of these factors are identical, if you'd like to, you could simplify it a little bit and write that quantity as x plus 2y squared. But it's not required and it's not necessary. You can leave them separated. This is homework number 100. It starts with question 1. It has 6x squared minus 36x minus 432. Remember, as you complete assignments, please forward them to me. Either make them PDFs or send them by text as pictures. One assignment at a time is easier for me. If you have questions while you're going through your homework, please make sure you call me or text me or send me an email. Otherwise, have a great day.